All right, in 3.7, there's one more thing I need to discuss, and it's standard forms of arguments. So actually, most of the arguments that we did using truth tables can be solved if we know these standard forms. So for example, if your premises are that P implies Q and P, therefore Q, this is considered a valid argument, and this is direct reasoning. So these are all examples of standard forms of valid arguments, and here's standard forms of invalid arguments. And so let's go ahead and look at the ones we were doing, and let's see which of these we could have done just using this table we have. So here we had P implies Q, not Q, therefore not P. So let's see if we have that on our list. P implies Q, not Q, therefore not P. So this is what we call contrapositive reasoning, and that's a valid argument. And so I didn't have to do the table if I knew this form of direct reasoning. So this is direct reasoning, or no, I'm sorry, this was contrapositive reasoning. So basically, we can use the table to show that this is a valid argument, or we can look at our standard forms and we find this one here, and so we could just say, hey, by contrapositive reasoning, this is a valid argument. Let's move on to the next one. Let's see. So here we have P implies Q, and then Q as our premises, and then therefore P. So do we have that on any of our valid arguments? So we don't see that up at the top. So P implies Q and Q, that's this one here. So this, let's see, we had P implies Q and Q as premises, and then not P. So that was this case here. So this is an invalid argument by the fallacy of the converse. So let me just get myself organized here. Fallacy of the converse. All right, let's go to number 3. We have P implies Q and not P implies Q. So here we have P implies Q, but this is different. See, not P implies Q, that's not, yeah, we don't have any, this is not one of our standard forms. So on number 3, we showed that it was a valid argument, and it's not one of the standard forms, so we wouldn't be able to use this table to determine whether it's an argument or not. Let's move on to the last one, number 4. So here we have P implies Q and Q implies R as our premises, and then our conclusion is that P implies R. Now you may recall, let's see, P implies Q, Q implies R, so P implies R. You may recall in geometry a property called the transitive property. That's what we have going on here. And you can see it's here. P implies Q, Q implies R, so P implies R is our conclusion. And so that is considered transitive reasoning. And so if we had the option to solve this, notice it did say use a truth table here, but if it had said that we could either do that or use a standard form of argument to determine its validity, we could have said that this is transitive reasoning. So using a truth table, we could prove that it's a valid argument because we had a tautology here. But if you had the option and it said you can use a standard form of argument, then you wouldn't have to do this. If you recognize that this is transitive reasoning, it was this case right here. Or wait, I'm sorry, this one here. All right, so that's it. And again, if you have any questions, just let me know.